Okay class, this is our Unit 2 test review. Make sure you get your parent signature. There might be some extra points on your test if you get your parent signature. Show them what you have to do. I think that you might impress them with what you know. Okay, so I've kind of already gone through and set up each of the questions, so what I would recommend is listening to me explaining it, and then you can pause it and take the time to go back and actually finish working the problem. So I've made sure and highlighted the important things to pay attention to and write some little notes on here for you. But this table, it shows the time it takes a snail to travel different distances. What is the constant rate of change, which we've talked about is just a fancy way of saying the unit rate, or what does it take for one, in this case, minute. How far can you go in 1 minute? So like it says in this situation, inches per minute. So we're wanting to know what he can do in 1 minute. Well, that's easy. We just set up a WKU. So my words, since it's inches per minute, I put inches per minute. And then you can use any of these pairs. You could use 9, 13, 12, 17.33, and so on. But I chose 9 and 13 because there was no decimals. I'm making it easier for myself. So make sure the inches is on top, 13 over time, 9 minutes, is set equal to, okay, x is how many inches in 1 minute. So you're just going to cross multiply and divide. Now it was nice on the first couple, I actually did the cross multiplying for you, so 9 times x equals 9x, 13 times 1 is 13. Then to get x alone, we would divide by 9 on both sides, and that will give you your x, which is the distance they can go in per minute, inches per minute. Okay, so now I would pause on that one and go back and work it. Okay, and make sure that you understand. Don't just take the don't do this last step. Make sure you understand how this problem works. Okay, number 2, Chelsea's dad filled the gas tank in his truck and spent $49 for 17.5 or 17.5 gallons of gasoline. What is the constant of proportionality? Again, just the unit rate in this situation. So the unit rate, we just want to know what is the price for 1 gallon. We know the price for 17.5 gallons. We need to know the price for 1 gallon. So we just set up a WKU, dollars per gallon. We know that there's $49 spent for 17.5 gallons, which we can set a proportion, since this is proportional, equal to how many dollars per 1 gallon. Okay, you'll cross multiply and divide. Again, I've set that up for you here. And when you solve for x, that's going to be a dollar amount. So if you get some crazy number that doesn't seem like a normal price for 1 gallon of gas, say you get, if you multiplied wrong, I'm trying to think of a way you can multiply wrong. But if you got like $6, even that is too high for a gallon of gas, so you've done something wrong and you need to go back. If you get a decimal, so not even a full dollar, that's way too low for a price of gas. So you know you've multiplied, you've divided wrong, you need to go back. Okay, always think, and I've done a good job on each of these, of writing out what your answer means so you can figure out if your answer is reasonable. Did you multiply and divide right? So this is going to give you the price per gallon, or the price for 1 gallon of gas. Okay, number 3, the cost of Miss Duncan's electric bill increased by 8% to $112.80. What was the cost of her electric bill before it increased? So this is a percent increase decrease situation. So change over original equals percent over 100. Okay, this is always going to be a 100. Our percent, okay, 8%. However, since it's increased, we've taken the whole price of what the electric bill was before plus the 8% now. So that's how we get 108%. Okay, and then to figure out which one the 112 is, change your original. We don't know the original. We're trying to figure out what the bill was before it increased. So we're looking for the original, and the changed amount is $112.80. Okay, the biggest thing is you're just having to think about, okay, this is set equal to 100% or 108%, because this is the price, the full 100% of the price before it increased plus the 8% increase. So this is equal to 108%. This, what we're looking for, is going to equal the 100% that it originally was. So you'll just cross multiply and divide that to solve. Okay, Number 4, this is one that you cannot be lazy on. Tasha was pricing ice cream for a party. They sold 4 different brands of the same type of ice cream. So each of these, here's the brand, and then the ounces and the price for it. It wants to know what the unit cost is, or the price for 1 ounce for all the different brands. Place them in order from least expensive to most expensive, or basically small to big. So you just have to set up 4 WKUs, okay? And on your test, you're going to have one like this, and if you want to get the problem right, you cannot be lazy. You have to take the time to work out each one. Okay, so I've actually gone through and set each of them up for you, so now you just need to go through and solve them. But I want you to stop and look at how I've set them up. Make sure if I hadn't given you this that you would be able to set them up on your own. Okay, so like this one, all of them are dollars over ounces, price per ounce. I took what I know, price on top $3.90 over 6 ounces, and set it equal to the price for 1 ounce, okay, on each of these. So you'll want to solve, and then wherever you have room, write them in order from least expensive to most expensive. Okay, number 5, Mr. Timmons ordered 5.5 or 5.5 gallons of water for his class to use during a science experiment. Here's what we know. 1 gallon is approximately 3.79 liters. So he's asking, how many liters did Mr. Timmons order? Remember, he ordered 5.5 gallons, so we want to know what this is in liters. So again, a WKU. Our words are gallons per liters. You could flip those. You could have liters over gallons. You just have to stay consistent across. Meaning, up top right now, everything up top is a gallon amount. So 1 gallon is 3.79 liters. So if he bought, Mr. Timmons got 5.5 gallons, we want to know how many liters that is. Cross multiply and divide. Your X will be the amount of liters for 5.5 gallons of water. Okay. Number 6, the band boosters created a budget for 175 students to attend a banquet with a per person food cost of $3.75. If the number of students attending the banquet was 72% more than expected, then how much would the amount budgeted for food increase? So this is a percent increase situation. We first need to figure out how many more people are coming. So we use our percent increase formula, change over original equals percent over 100, and we say, okay, that's always 100. It increased 72%. Originally, they had budgeted for the 175 students. So we want to say X, how many students is that changing? How many more students are coming? So when you cross multiply and divide, and I went ahead and did this full one for you, we got 126 more people are coming. Okay? So that's not your final answer, and I promise you on your test, this number will be an answer choice. You have to know that there's more to the problem. You cannot get distracted by the answer choices. Okay? So 126 more people are coming. For each person to eat, it costs $3.75. So what you have to do is you have to take $3.75 per person and multiply it by the 126 more people. Okay, so when you do that, do not forget about where to put your decimal. That is going to tell you how many dollars more they're spending than budgeted. If you get a crazy amount right here, you have to know it's reasonable. That can help you identify, ooh, maybe I put my decimal in the wrong place. Maybe I multiplied wrong. Make sure that this is a dollar amount. Make sure it's reasonable for the price that they're paying for these 126 extra people. Alright, number 7. The water readings on a tank are shown in the table below. What is the constant rate of change? So again, that's unit rate, or just what it can do, in this case, per hour. So it wants to know what the water level does in an hour, for 1 hour. Okay? So we have to look, and I could use any of these, but really I was able to see from 550 to 650, that's 1 hour, okay? And so from here to here in 1 hour, what happened? It went from 60 gallons to 30 gallons. So from 550 to 650 in 1 hour, the water level went down or decreased by 30 gallons, okay? Which is 60 gallons minus the 30 gallons, okay? I will tell you on your test, this is, you're not given a chart, you're given like water meters, and you're going to have to be able to read those and see which ones are an hour apart to tell what the water levels are doing per hour. Number 8, Aaron earns $1,500 each month. selling cosmetics. She wants to save a total of $3,600 or $3,600 for a trip to Asia over a 1-year period. What percentage of Erin's total monthly budget should go to her trip savings to meet her goal? Okay, so in 1 year there's 12 months. So she has 12 months to save her $3,600. So what you need to do is find out how much she needs to save each month. So what we do is we take the total she needs to save, the $3,600, and divide it up by the 12 months she has to save it. When you divide these two numbers, you get that she needs to save $300 per month if she's going to meet her goal. So that's how much she needs to save per month. Okay? I promise, again, on your test, this will be an answer choice. This is not your final answer, so you need to know, oh, that's not, you need to know what the question's asking so you can be able to say, I'm not done with this problem. Okay? So now what we do is it's a part over whole equals percent over 100. So the part of her budget that she needs to save is $300 over her total or her whole budget, which is $1,500 each month. So part over whole, $300 out of the $1,500 she makes each month will be equal to whatever percentage she's needing to find. Okay, and you can put an X there. I just left it as a percentage so you would know. Cross multiply and divide, and that's going to be the percent of her budget that she needs to save. So you need to recognize that that is a percentage of her budget, so you need to think realistically. If you got 90%, there's no way she can give 90% of her budget to savings and then just live off of her food, her rent, her gas, all of that 10%. So this needs to be a reasonable amount or percent of her budget that she's saving. Alright, number 9. The following figures are similar rectangles that have a proportional relationship between the base and the height. Okay, so they said base first and then they said height. So the base to height of each rectangle. What is the constant of proportionality? Meaning just kind of that K that we talked about. Again, it's the unit rate, but when we don't have, remember we talked about your constant of proportionality is K, which we kind of find by taking one number divided by another, between the lengths of the bases and heights in each rectangle. So basically we're just finding the base divided by the height, the base divided by the height, the base divided by the height. If these rectangles are proportional, that number that you get when you take the base divided by the height for each one will be the same. So what you need to do, I've set them up for you. Here's your base, here's your height. I forgot to put the T. Height. When you divide each of those numbers, each of these need to give you out the same thing. If it does, these three rectangles are proportional. Alright, number 10. At the craft store, Sarah found a bolt of fabric measuring 5 meters in length, which is also 16.4 feet. She finds another bolt of fabric measuring 59.04 feet, but the measurement in meters was torn off the tack. Use a proportion to find the length of the fabric in meters. So we set up a WKU. We've got meters over feet. You could have feet over meters. You just have to know that you're going to need to stay consistent throughout. So meters per feet, I know that 5 meters in length, 5 meters, is also considered or is equal to 16.4 feet. These are the same measurements, you're just measuring them in different units. So 5 meters is 16.4 feet. We're setting that equal to say, okay, she has, what did she get? She has a thing of, it's 59.04 feet, so we put that on bottom, feet, and we want to know what that is in meters. Okay, so we set that up top, so that's what we're solving for. We'll cross multiply and divide to figure out how many meters this yard, or this, what do they call it, bolt of fabric is. Okay, this one, you have to promise me you will not get scared when you read this whole paragraph, okay? Really, it's actually a very simple problem because they tell you this formula, R equals D divided by T, which I've written out for you, just means rate. The rate of something equals the distance divided by the time it takes to go that distance. So reading all of this, and that's in here, where D the distance, or where distance D was measured in feet and time T was measured in seconds. So back up here they discovered it took 0.62 seconds, so that's your time that I've wrote out for you, to travel 50 feet. That's your distance. Okay, now it wants to know the rate. Well, we know the distance divided by the time equals the rate, so that's all we have to do. We take the rate will equal the 50 feet, the distance, divided by the 0.62 seconds, the time, and that will give us the rate. Now when you get this rate, it is feet per second, okay, and it even says it right here in feet per second to the nearest hundredth, so you may have to round. But again, you need to make sure that this answer is reasonable. Alright, number 12. John rode a horse a total of 154 miles in 7 days. Each day he rode 8 hours and then stopped for the night. What was his average speed in miles per hour for the 7-day trip? Okay, so the first thing that we have to do is we don't have a level playing field here. We know days and hours and miles, but we just need 2 words for our WKU. So what we have to do is we have to find out how many total hours he rode. So if he went 7 days, and it says each day he rode 8 hours. So we're going to take our 7 days multiplied by the 8 hours each day to give us total he rode his horse 56 hours. Now we can set up our WKU. Again, on a test, this would be an answer choice. You have to know you're not done. You have to know what the question's asking so you know when you've completely answered the question. Okay, so your WKU, miles per hour, okay? And it even, a lot of times at the end, like this question said, what was his average speed in miles per hour? Those are your words, right there, miles per hour, okay? We know total he went 154 miles, right there, in 56 hours, and we got that ourselves. We figured out total, it took him 56 hours to ride his horse those 154 miles. So we set that equal and say, okay, how many miles per 1 hour? How far did he go in 1 hour? So you'll cross multiply and divide this, and that will give you your x will equal how many miles per hour he went. Now remember, he's on a horse. Think reasonably about how far you can go on a horse in 1 hour. Okay? So if you've got even 10, well, I don't know. If you've got 80 miles, a horse cannot go 80 miles per hour. Okay? So that's what a car drives. Okay? So that cannot be your right answer. You have to think about what your answer means and know if the number you get is reasonable. If it's not, go back and check your multiplication. If it's not, check your division, check the proportion that you set up, but always make sure that your answer makes sense. Okay, I think this is the last page. So the table below shows the Smiths family budget last month. About what percent of their monthly budget was spent on gas? Okay, and it says round to the nearest percent. So what you need to do is, this is a part over whole equals percent over 100 situation. And you know that they spent $250 in gasoline. Okay, you need to figure out how much money they spent total. What was their whole budget? So you have to actually add up 975 plus 250 plus 325 plus 305 plus 245. You have to add these all up, and that's your whole. That's your total budget. Then you say, okay, out of my whole budget, I spent $250 on gas. Okay, so you say part over whole equals what percent out of 100. Okay, then you'll cross multiply and divide. But the big thing is, you're not going to be given the whole. You have to find it. You have to add up everything that they spent money on to get their whole budget. 250 out of the total budget will equal what percent? Okay, last one. Victor runs 2.5 miles in 1/3 of an hour. At this rate, how many miles could he run in 4 hours? Just a WKU. We're talking about miles per hour. What we know is that he can do 2.5 miles on top in 1/3 of an hour. The reason that I did not switch this to a decimal was because 1/3 is a repeating decimal. So I left them as fractions. Okay. You could probably switch it to 0.33 and get a rough estimate, but since this is, on a test you could do that because it's multiple choice, but on this you're going to have to multiply with these fractions because you don't have answer choices to choose from. Okay, so anyways, he could go 2.5 miles in 1/3 of an hour, so we set that equal and say, okay, how many miles can he go in 4 hours? Okay, and you'll cross multiply and divide. Remember that this is going to give you how many miles he can go in 4 hours. Okay, so this is a person running. Victor's running. So he probably can't run over 30 miles in 4 hours. unless he's some sort of Olympic runner, okay? So if you get anything above even really 20, that's not very reasonable. But however, if you get like 2 miles, he should for sure be able to run 2 miles in 4 hours. So know what your answer's meaning, and so you can determine if it's reasonable, okay? And on a test with all this reasonable stuff, on a test you should be able to cross out some of your answer choices. You should be able to, when you have your A, B, C, and D, you should be able to cross some of those off. Knowing before you even start working, you should know, okay, the answer can't be this because this number is way too small, or this number is way too big. Okay, so use that to help you take advantage, okay? Alright, so make sure again that you've shown, I've set these up for you, but this is not all you need to do. You've needed to go back and cross multiply and divide or finish solving each of these problems, okay? Again, make sure you've got a parent signature for some potential bonus points on your test. Okay, let me know if you have questions. Thanks.